Hello, my name is Aybüke Ayhan, and today I will be presenting the experiment I conducted for my Physics 101 course, titled Measuring the Coefficient of Friction on Various Surfaces. This experiment aims to explore how static and kinetic friction coefficients vary depending on surface materials. The main objective of this project was to determine both the static friction coefficient and the kinetic friction coefficient for different surfaces, including wood, glass, and sand, using an inclined plane setup. In theory, friction is a resistive force that opposes relative motion between two surfaces. Static friction must be overcome to initiate motion, while kinetic friction acts once the object is already moving. Static friction coefficients can be calculated using the formula, where is the critical angle at which the object just begins to slide. Similarly, the kinetic friction coefficient can be found using Newton's second law and the formula, where is the gravitational acceleration is the angle of the inclination and is the measured acceleration down the plane. The procedure of this experiment was conducted as follows. First, an inclined plane with different surface materials was set up. A wooden block of approximately half kilograms was placed on the surface. Gradually, the angle of inclination was increased until the block started to move, and the critical angle was recorded. Next, using this angle, the static friction coefficient was calculated. For kinetic friction, the block was allowed to slide a known distance of 1 meter. The time taken to cover this distance was measured using a stopwatch. From distance and time, the acceleration was calculated and then used to determine the kinetic friction coefficient. These steps were repeated for each of three surfaces: wood, glass, and sand. Here is the materials I used for this experiment, and here are two videos I recorded. In this one, I am doing the experiment on sand surface, and in this video, I am doing the experiment on the glass surface. Now I'm going to move on with the data and the results I found while doing this experiment. This is the graph I obtained while doing the experiments, and additionally, the graphs showing the variation of static friction coefficients and kinetic friction coefficients and acceleration across surface types were plotted in my experiment. In the case of errors in my experiments, several factors may have introduced uncertainty in the measurements, like inaccurate reading of the critical angle due to parallax errors, manual timing errors caused by human reaction delay, surface imperfections like dust particles, and minor air resistance and mass distribution irregularities. Estimated uncertainties were approximately plus or minus 1 degree for angle measurements and plus or minus 0.1 seconds for time measurements. In my discussion, as anticipated, the static friction coefficient was higher than the kinetic friction coefficient across all surfaces. The highest friction values were observed for the sand and gravel surface, while the lowest values were measured for the glass surface, reflecting the smooth nature of glass. The data agreed closely with the theoretical expectations and typical values found in the literature, confirming the validity of the methods I used. For future experiments, there may be some improvements can be done. by using a photo gate timer to eliminate reaction time error and a digital inclinometer to measure angles more precisely. Also, testing with multiple masses and investigating lubricated surfaces could provide further insights. In conclusion, this experiment successfully In conclusion, this experiment successfully determined the coefficients of static and kinetic friction for different surfaces. The results align with theoretical principles of friction, highlighting the dependence of friction on surface material properties. And that's all. Thank you for your time.